Well, hello everybody on the internet. So today we're not going to be working on Frogger like I expected, basically because in the last week I've come up with a game idea that I'm really enjoying. And Frogger's a game that has been done a few times, and I'd almost completely forgotten that Crossy Roads is a thing and that's big, so we'll let them do Frogger. I've got a different idea and I've been enjoying working on this. This is Whack. So I'll give it a quick run and demonstrate what I've got so far. So here we have a map, and we have a little guy in the middle who can walk around, and as he moves he pulls this ball on. Now if he gets hit, currently if the guy gets hit by the rats, he dies, but if I can hit the rats with the ball, they die. Other things I'm quite proud of getting working. One is the ball bounces off the walls quite nicely. Like that, and that bounce is really quite usable as part of the of your battles, and so that will definitely be part of the bigger game when I get it moving. It also goes over the sea, but you can't, which was quite an interesting challenge. It meant playing with engo and basically ripping up the collision mechanism and adding what is a bitwise collision detection. So some things are in different groups based on a bitwise comparison. So I was quite happy with that result, and I'll probably suggest that as a change to the guys at Engo. Good news, by the way, one of the guys at Engo has liked my contribution. They haven't yet accepted it as a pull request, but hopefully that will happen in the near future. That would be quite exciting, and then I'll be able to start making some more contributions. I've got some other ideas for things that I would like to change about how it works, basically to use interfaces more. I really think that interfaces need to be used wherever they can. The other thing, in case you haven't seen, it is keeping track of the score. At some point I'm going to add that heads-up display, which is quite doable. For now, I'd like to show you a little bit about some of the things I've done, or how I've got some of this working. So first I want to talk about how the draggable system works, because I'm quite chuffed with that. So that is, it seems like there's a rope between the guy and the ball. So I'll show you how I've got that working, and then I'll show you how we got the rats doing their movements. Let's take a peek at the code, shall we? First to the draggables. So vim play stroke draggable.go. So everything that happens in draggable, so the first thing I've done in order to make dragging happen is we have an object. Every object that can be dragged has a drag component, and a core part of that is they have to have a weight. So a heavier object will pull harder on a lighter object. That helped me to allow to have my triangle guy, who will later be a picture, pull the ball more easily than the ball pulls him, but the ball does pull back. We'll get to that in a minute. Get drag component, again this is to meet the interface thing. I talked about the interfaces last week and probably the week before. There is a draggable interface which I've used, which basically requires you've got a basic entity, a space component, push, which is the method, which velocity components. I created velocity components, and again that's a thing I think could do with being available to more people, so I'll see if I can get that in the library at some point in Engo, but I'll save that for now. And so by having the method push, that means anything that can be pulled by the rope can be. So push basically takes a point and changes its velocity by adding that point to its velocity, and then on the movement system that gets added to its current location. This is quite handy because you can then basically you just need to think F equals ma. Everything that changes their direction, you apply a force and that pushes them in that direction, and so that leads to some realistic physics. I'm quite happy with that. And get drag component, obviously you need to be able to drag, so the drag system, there's the tether as well. This is our type that actually creates stuff. This has a basic entity, so these can be treated by other systems. There's two draggables, a primary and a secondary, I guess, two things that it drags, that connects, and a tension and a length. So if they are closer than the length of the rope, then we don't do anything, but if they're further, then we use the tension to calculate how much pull we need to put. And then the drag system, which obviously needs a list of tethers, and each tether contains the two things that it drags together. And then our method, instead of writing an add method, I decided to put a connect method. So this takes two draggables. So anything that has the requirements to be draggable can be connected, and then a tension and a length. And then we just create the tether and then add it to our list of tethers. Remove, I haven't done that yet. I probably will at some point. It's not that complicated. But I've just left stuff connected from the beginning, so that's why. And then the update, the core of this, is I go through all of the tethers, then I get the space components and calculate their center, so that's what I'm going to work with. And so that's A and B, the two objects, and then I get their drag components, which are basically their weight. Are they drag components? Did I call them drag components? I did, okay. So, but I need to get that, and then when we do is a quick comparison of their length, and oh yeah, here we go. So if the length is too short, the distance. Yeah, I'm glad I didn't have to bother calculating this. So I need to calculate their distance, and that's just 2 points apart from each other. So it takes A dot position dot point distance from B dot position. I actually think this is wrong. This should be center, shouldn't it? Not that it makes a whole lot of difference, but the distance between them that I'm actually working with here should be ascend. Otherwise I'm doing the distance from the two corners. And that should probably still work. I'll test it once I finish showing you the rest of the stuff in this page. So tension. So then we just do a quick thing and make sure the tension works, and we pull like that. And that's how the drag system works. And then this actually does mean that I can add as many connections and as many balls as I want, which I was quite happy to discover. So I'll show you what we can do with that now. Let's just check that this still runs. Go run main.go. So yeah, we still got that, and it's still dragging appropriately. And probably more appropriately actually, instead of based on the corners. And get that rat. Good. So if we then go to our main scene, and in here we have the place where we create all of the objects and add them to the systems. And here I take the system list and I add another ball, and this is how I've done it. I created a method called add ball, which basically makes a ball and it connects it to its partner by adding it to the drag system with a connect. So that means I can create lots of balls and connect them in different ways. Oh, and this also returns the balls. So if I go b colon equals, and then I can take b, and I is for the color, 0.1. I'll set its length to 10, so instead of being 70 long, we now have, oh, I was doing all the work in this. The plan was to work on this page and do that, so I'll try and remember that. Go run main.go. We should now have 2 balls, and they are connected to each other, but not to me. I could actually connect them to me and to each other and have a different thing. And I quite like the look of this because you end up with some good physics. So hopefully that will probably be added at some point where you get to use multiples. And with a bit of a for loop, I actually tried making like 100 balls and having them all connected, and I was quite chuffed with that result. Wasn't very playable, but I liked the look of it. So I'll get rid of, no, I'll add a few more, no. So I had another, that add ball method isn't actually needed here. So we'll carry on and back to normal. The other thing I wanted to show you is how we've got the rat chasing you, and how I've got them moving around. So a quick glance at the picture. So this is the image we're looking at. Hopefully that will zoom in if I push up a few times. It's not a particularly fancy image. 8 pictures of a rat, and as I see it, this is facing in order around the circle, up, right, and so we go. There are 8 degrees to a circle when I draw a circle. And there's another one for a red rat. And if I go vim, no. There are 2 things. One is spawn, vim play spawn.go, which loads the scene, I believe. Oh no, we still need main scene, tab edit, play, and tab edit enemies. Oh, so let's start with the scene, because if you want to load images, you have to use, it's good to use the preload method to make sure you've got them in. And in the scene preload, making sure we just make sure we have loaded rat and rat2.png. That's the red rats. Looks basically the same, really badly coloured in. And that's all you need. So I've just done it with an error, so I know that why it fails if it does fail, but shouldn't be a problem for now. And then in spawn.go, the spawn system has a list of sprite sheets for the appropriate enemies. And when it gets a chance to do a spawn, basically it picks a random number, 0 or 1, and chooses the appropriate image and level for the items, because the red rats go slightly faster, so I had to include that speed when I made my new rat. And that's basically all I did. I sent it a sprite sheet. So we get a sprite sheet, common.spritesheet from file, and then this already has to be loaded before this can work. That's done elsewhere in Engo. They load up PNGs and make sure that they are GL textures ready to be used, and that's the width and height of an individual image within that sprite sheet. So then you can find them by frames appropriately. And when I made a rat, I also needed to... Oh no, that's right. I'll show you the enemies system. I think it was in enemies. we have the type of boxy, so this is the actual. Yeah, this shouldn't still be called boxy. I left it called, when I was first playing the game, they were boxes. I didn't know how they were going to move. That's why they were called boxes. Just straight up squares, really, just chasing after me. And the box system works by having 2 sets of array lists of. I'm still speaking Java. 2 sets of slices. We have a slice containing boxies, which are the rats, and targets. So the rats will chase after whichever target is closer. So when you add a target, it just appends it to the targets, and that's a spaceable. And if you add spaceable, is just an interface to make sure it's got a space component and a. That's the only thing it really needs, is a space component, so you can chase it. And add box, does the same, just adds a box to the boxes. And then on update, which happens 60 times a second-ish, we go through our list of targets. If there are no targets, then we don't do anything. If there are targets, we chase after them. So first we loop through the boxes. And here's where we loop through the targets to make sure we've got the closest. So for t in range of bs.targets, we just get their space component, look at their center, and compare the center distances, and if they're nearer, then we change our target. And then we do this thing. Basically, it's if we're more to the right of it, then we add some force, which is the acceleration, which is basically chosen by their length, by the level. So some rats accelerate faster than others, and that's what we've used based on the levels. So we just accelerate it towards, using push, that changes its velocity, not its position, meaning that they kind of accelerate towards you at a nice, happy pace, nothing too scary or sudden jumping. I was really happy with one of the results of this. If we watch the rats right now, they kind of chase after you, and as you see, they are just accelerating towards me, but the angles of their body is changing to match that using the sprite sheet. I was really happy with how that came out. I'll talk about that now. And here's how I've done that. So once I've started pushing them in the right direction, I actually that's funny because push is a method of a velocity component. So if they had this push, it's very likely they had get velocity component, but we require that they have this method, get velocity component. And we take this velocity component and we call this method in a engo point is a points-based library I've included in my own thing, and it's called angle8, which basically says, based on the vector, which direction is it facing? Is it facing up? Is that because that would return a 0? If it's facing north, northeast, then that would be a 1. East would be a 2. Southeast would be 3. South would be 4. Then 5, 6, 7 around the circle. And that method is basically just a bunch of if statements wrapped together. But I feel like I can use that quite a lot, especially when I'm so happy with the result from the rat that I can just tell which way it's facing and then apply the right picture based on its velocity. And then I have a render component which obviously needs to check. Oh, that's right. And then I set the render component. So I get the render component and I set its drawable to the cell, which returns a drawable. It returns something that fits the drawable interface. It returns based on the number, and that's why I have the pictures the way round they are, with 0 at the top and then 1, 2, 3 around the circle. Hopefully you'll find that information helpful in working out how you want to do stuff in your project. If you do, let me know. If you don't, let me know, and have a good week or so. Bye for now.